Okay, continuing on with series, and now something that is going to involve quite a bit of number crunching, and we have in the realm of approximating radicals using power series. And again, we have just a layout for power series. Okay, we have again just the algorithm, and for the items we're going to be looking at in approximating radicals, technically we're not going to have the series per se to end, but we're going to carry out to just what we have in the fourth degree. And let's say we have, as an example, say we're looking at approximating the square root of 39, and say we carry out to the equivalent of x to the fourth. And I'll get to that very shortly. Now for the number 39, okay, that is not a perfect square, and the closest perfect square to 39 is going to be 36. So if I were to write the square root of 39 in terms of the square root of 36, so you have like 39 is more than 36. So we can say we have initially 36 times 39 over 36. And the fraction is reducible to 3/12. And just putting it more in proximity with what we have in our power series expansion. Okay, now we got the square root of 36 is 6, and 13/12 is going to be 1 plus 1/12, and its square root we have as 1 plus 1/12 raised to the 1/2 degree. So we have in the case of the power series expansion, okay, so you would have like x would be at 1/12, while p is going to be at 1/2, and carrying out to the equivalent of x to the fourth, so you have 1/2 taking 0, 1/2 1, 1/2 2, 1/2 3, 1/2 4 for the binomial coefficients. And you have for x to the fourth, we're looking at carrying out with x at positive 1/12 raised to the fourth. And now for 1/2 taking 0, okay, the bottom number is 0, so that goes to 1. 1/2 taking 1 would go to 1/2 the top number itself. Now, where we do not have the automatic reductions, we have like in the case of 1/2 taking 2 at a time. So you're looking at, again, you have p factorial over r factorial times p minus r quantity factorial. So you have 1/2 factorial all over the product, 2 factorial, and the factorial of negative 3/2. Now, as a standalone, there's not exactly negative 3/2 factorial in the real number sense, but if we look at expanding, say if we write 1/2 factorial in terms of negative 3/2 factorial, so you have like 1/2 times 1/2 minus 1 times 1/2 minus 2, so this leads up to negative 3/2, and the factorial of negative 3/2 we have in both the numerator and denominator. So if we cancel, we have the numerator, we have 1/2 times negative 1/2 is negative 1/4. 2 factorial is 2, and negative 1/4 over 2 is negative 1/8. And kind of running through the mill, okay, so we have with the bottom number at 3, so you have 3 factorial. 1/2 minus 2 is negative 5/2, and same kind of expansion, and carrying out 1/2 factorial in terms of negative 5/2 factorial. So the numerator, we have 1/2, negative 1/2, and negative 3/2 multiplying out to 3/8. 3 factorial we have at 6, and the simplification we have 3 over 48 reducing to 1/16, and with 4 as the bottom number, so 4 factorial would be 24, and 1/2 factorial in terms of negative 7/2 factorial. Once you cancel out negative 7/2 factorial, you have the product of 1/2 times that minus 1 minus 2 minus 3. So you have 1/2 times negative 1/2 times negative 3/2 times negative 5/2. So we have negative 15/16 over 24. So this will come out to negative 5 over 128. And so for what we have for 1 plus 1/12 to the 1/2, and just filling in the values. Okay, so again, 1 times 1, 1/2 times 1/12. And you have negative 1/8 times the square of 1/12. And then we have, again, 1/16 times the cube of 1/12. And again, 1/2 taking 4, we have at negative 5 1/28 times the fourth order of 1/12. And just with my calculator, we have in terms of the expansion, we have 1.040832896. And going back to our original problem for the square root of 39, Okay, so we have 6 times, again, 1 plus 1/12 quantity to the 1/2 and carrying out to the 4th degree. Okay, so you got 6 times our recent numerical result. And we have, for the square root of 39, with this approach, we have at 6.244997378. And in comparison to the so-called exact, okay, so if you notice, you have close proximity, so we have 6.244997, and then once you get to like the 7th decimal place after the point, okay, this is where you have a bit of divergence, okay. And another case of approximating radicals, and say if we go from dealing with square roots to cubic roots, like we had the cubic root of 25. Now the nearest perfect cube is going to be 27, which we have 27 to be 3 cubed. And if I look at writing 25 in terms of 27, now 25 is going to be 25 27ths, and writing in terms of power series expansion. Okay, so we got 25 27ths, so it would be 1 minus 2 27ths. And setting things up, so we got the cubic root of 27 is 3, and we have for the cubic root of 1 minus 2 27ths, that'll be that difference raised to the 1/3. And in terms of the power series expansion, okay, so we got the p value is going to be at 1/3, and your x is going to be at negative 2 27ths. Okay, so we're going to carry out to where we have to the 4th degree. And again, just looking at what we have here. Now we can reduce the first 2 terms in the series, and looking at where we had to do or apply the added elbow grease for the bottom numbers and the binomial coefficient 2, 3, and 4. Again, with the bottom number at 2, okay, we have 1/3 factorial all over the product of 2 factorial and 1/3 minus 2 factorial, which we have at negative 5/3 factorial. And writing 1/3 factorial in terms of negative 5/3 factorial. Here we have, in expanding, the factorials of negative 5/3 will cancel. And so left over in the numerator, we have 1/3 times negative 2/3 is negative 2/9. 2 factorial is 2. And the reduction we have at minus 1/9. And with 3 at the bottom, okay, you have 1/3 factorial all over the product of 3 factorial and that of 1/3 minus 3, which we have at negative 8/3 factorial. And again, just expanding, you have 1/3 times 1/3 minus 1, minus 2, minus 3, developing negative 8/3. Anything subsequent, okay, we have after negative 8/3, but we don't need this since we're going to have the cancellation of the factorials of negative 8/3. And just for the simplifying the numerator, we have 10 27ths. Denominator, we have 3 factorial at 6, and the complete simplifying leads to 5/81. And with 4 at the bottom number, okay, this time we have same kind of expansion and carrying out to negative 11/3 factorial, which will cancel. And so for the remnants, okay, you have the numerator terms remaining lead to negative 80/81. 4 factorial leads to 24, and the simplifying we have at negative 10/243. And just with the follow through, okay, so we have combining our terms, okay, and again 1/3 taking 0 leads to 1. Any non-zero value to the 0 power is 1. 1/3 taking 1 leads to 1/3 the top number, and just filling in for the rest and up to the 4th order. Okay, we had the approximation at 0.9746726508. And going back to our original problem, so the approach we have taken, if we approximate the cubic root of 25, we have right at 2.924017952. And comparing to the exact value, so you have a lot of proximity here. So you have 2.9240117, and okay, and where the exact has 7, we have 9 in our approximation. And again, we have the offset right at about the 7th decimal place. All right, so a very good approach in terms of approximating. Now, something that will require a bit of number crunching, and software might come in rather handily. And we have with the 4th order, or the fourth root of 2000, but we have the nearest perfect fourth is going to be 2401, which would be 7 raised to the fourth. And if I write 2000 in terms of 2401 and just setting things up, so we have the fourth root of 2401, which is 7, and we have 2000 over 2401. Okay, that's going to be written as 1 minus 401 over 2401. And with the fourth root, we have to the 1/4 degree. And so just carrying out what we have and putting in terms of power series expansion. Okay, so still going out to the fourth order and just kind of looking at what we have now with 1/4 representing P in this case. All right, and so we have, before we get too far ahead, so just to kind of formalize, so we're looking at, again, this difference raised to the 1/4 power. Okay, so we have with 1/4 taking 2 at a time, you got 1/4 factorial all over 2 factorial. 1/4 minus 2 is negative 7/4 factorial. Same kind of expansion as what we had earlier. And just simplifying, this comes out to negative 3 over 32. And with 3 at the bottom, okay, we now have the factorial to be canceled. Okay, it's going to be negative 11/4 factorial. And we have in this round, okay, we have upon simplifying, we have 7 over 128. And with 4, okay, so this time we have expanding out to negative 15/4 factorial, okay, which will be canceled. And simplifying, we have negative 77 over 2048. And so for what we have in the case of the expansion, and again, so we have to the 1/4 power for this difference. And just filling in the numbers. Okay, so taking 0 leads to 1, taking 1 leads to the top number, 1/4. And again, filling in for the binomial coefficients where we had 2, 3, and 4 at the bottom, indicated in blue. And we have multiplying by the power. So what we have with negative 401 over 2401. And we have putting together, so we had the sum to be between 0.95 and 0.96, where we have 0.9553475,189. And going back to the approximation of the fourth root of 2000, and so we have 7 times this decimal value, so we have right at 6.687432633. And compared to what we have with the exact, okay, so the exact we have 6.687403005, and so you have a little bit of an offset, okay, at about the 5th decimal place after the point. So it is a bit painstaking in terms of working with the fractions, especially like that negative 401 over 2401. But again, it is a viable approach, and there are some other methods. Like if you had something like Newton's method, as I recall, that could be a very painstaking procedure. So if you think that the power series is painstaking, there are other methods. Those still accurate, they can be quite a hassle.